Okay, so these are the notes for 9-2. We're looking at the next piece of trig, which is super important, which is understanding radians. So 9-2 and 9-3 will really encompass radians. We're going to talk about the unit circle in 9-3, but your understanding of radians is going to be really crucial to next year and in calculus. So you want to make sure you understand that. Email me if you guys have questions. All right, so let's talk about angles in trigonometry. So we call an angle in standard position. We call an angle in standard position if it's measured from the positive x-axis going counterclockwise. So we always start on the positive x-axis, we call that the initial side, and we move counterclockwise. That means we've got an angle measured in standard position. The terminal side then is where our angle is going to end, and that will be determined by the angle that we're trying to measure. All right, so if we take a look at this first example, we want to draw an angle with a given measure in standard position. We're always going to start by drawing an x and a y axis. I've got that for you guys here. And we want to draw 240 degrees. So we'll always start on the positive x-axis, and we're always going to move going counterclockwise if we're measuring a positive angle. So 240 degrees. 240 degrees is 180 plus 60. So 60 degrees is going to be a little bit more than halfway through the bottom quadrant here. That is 240 degrees. All right, 500 degrees, a little bit trickier. Now, 500 degrees is 360 degrees plus 140 degrees. That's how we get to 500. So a full circle is 360. That is us moving 360. And then we're going to go another 140. 140 degrees means we're 40 degrees shy of 180. So we're almost halfway through the second quadrant there. That is our 500 degree angle. We've got one spiral all the way through the circle, and then we're coming back around. Now, negative 50 degrees. We measure negative angles by starting on the positive x-axis and going clockwise. So negative angles are measured moving clockwise. Negative 50 means we're about halfway through this quadrant. We start on the positive x-axis, we're going counterclockwise. That gets us to negative 50, right? And that would be that angle right there. Okay. So we have this word called coterminal. And what that means is any angle that is coterminal with a given angle can be found by adding or subtracting multiples of 360 degrees. So if this angle here, for instance, is 0 degrees, then a coterminal angle with 0 would then just be 360. If we kept going, what is that, 720? And then keep going, that would be 1080 and so forth. So we're just adding 360 around and around and around in order to get angles that are coterminal. So 0, 360, 720, those are all angles that are coterminal with one another. All right, how about negative 45 degrees though? Well, negative 45 degrees, if I were to graph that really quickly, that's down here in the fourth quadrant. It's halfway through the middle of the fourth quadrant. That is our negative 45 degree angle. Okay, we want two angles that are coterminal with negative 45, and we want one to be positive and we want one to be negative. So let's start with a positive angle. If I want to measure this angle positively, we're starting on the positive x-axis. We're going to go all the way around till we hit that terminal side. Now, that is just 360 minus 45 degrees. This is 315 degrees. So one angle that is coterminal with negative 45 is 315 degrees. All right, let's try for that negative angle that is coterminal. So if this is negative 45, then another angle that's going to be negative that is coterminal with negative 45 would mean we're going clockwise. That's how we measure a negative angle, but we're going to go all the way around the circle and then come back down again. So we're just going to take negative 45 and add another negative 360 degrees. That purple angle is negative 405 degrees. So that is another angle that is coterminal with negative 45. Okay, so how did I do that? Well, we took negative 45 and we added 360 for the positive angle, and we took negative 45 and we subtracted 360 for the negative angle. That's kind of a good way to go. That's a good way to just kind of in general get positive and negative angles that are coterminal. All right, 395 degrees. Well, 395, we're measuring that as a positive angle. which means we're going to move counterclockwise. But 395 is bigger than 360, so that means we're going all the way around the circle, and then we're going to go another 35 degrees past that to get 395 degrees in total. So this is our 395 degree angle. Let me just draw that here. Whoops. Okay. There you go. Okay, so an angle that is coterminal. We need one positive, one negative. Well, because we wrapped around that circle more than once, what if we just did one less than one rotation around the circle? This is going to be then 35 degrees. So an angle that is coterminal with 395 is 35 degrees. That is taking 395 and subtracting 360. All right, how about a negative angle measure? Well, I can find one negative angle measure by just starting at the positive x-axis and going clockwise. If we're looking for that angle, that is just going to be 325 degrees in the negative direction. So negative 325 degrees is also an angle that is coterminal. All right, different ways to do that. Those are the two that work for me. There are many, many other options there. All right, 80 degrees, really, really close to that 90-degree angle. It's like 10 degrees off of that. That's our 80-degree angle measure. All right, let's talk about an angle coterminal. I can measure the negative angle like that. That is going to be negative 280. All right, that is just 80 minus 360. And then we can find another angle coterminal with 80 if we go all the way around the circle and then up to that 80. So that is just 360 plus 80. That is 440 degrees. Okay, an infinite number of angles that are coterminal with all of those. Those are just two of those options there. Okay, then now we have this concept. There are many ways, or two specifically, that we're going to be looking at ways of measuring an angle in trigonometry. With degrees, which we should be familiar with from geometry, and radians are really what we're going to be focusing on now in trig, and what you guys are going to see a lot of in pre-calculus. So what is a radian? I'm going to show you a diagram of what a radian is. I think it's going to make it a little bit easier to kind of see here. Okay, so the way that we define a radian is the angle made when the radius is wrapped around the circle. One radian is an angle made when the radius is wrapped around the circle. So the tricky thing about radians is it depends on the radius of the circle. So it's not consistent from circle to circle if they have different radii. We're going to use the unit circle later on when we get to trig, and that becomes really important because we've defined the radius in the unit circle. But take a look at this diagram. Let's see what I mean by the definition of a radian. So if we watch this video here, we take the radius, we wrap it around the circle and becomes part of that circumference, and that angle is 1 radian for that circle. All right, I think it's a good way to describe it other than looking at what the book's got to offer there. Okay, so today we're going to be focusing on converting between degrees and radians. There is a conversion that's pretty easy. I'm going to do a couple of these examples and I'll leave the rest for you guys. If we want to go from degrees to radians, let's say we've got 35 degrees and we want to move that to radians, we multiply by pi over 180. Essentially what we're trying to do is we are trying to get the units to cancel. So degrees are going to cancel because we've got degrees on the top and the bottom. Okay, similarly, if I start with radians and I wanted to go to degrees, let's say I have pi radians, we're going to multiply by 180 over pi radians. Again, we want the units to cancel. We've got radians on the top and the bottom, that will give us degrees. This comes from the relationship between degrees and radians. 180 degrees is always pi radians. That is something we'll focus a lot more on in 9.3 when we get to the unit circle. All right. Couple of examples here. I'm not going to do all of them on this page. You guys can go back and do some on your own, but you can use a calculator in order to do this. Okay, 120 degrees. We want to convert between degrees and radians. So 120 degrees, we're going to multiply by pi radians over 180 degrees. I want the degrees to cancel on the top and the bottom. And that is going to leave us with 12 pi over 18 radians, which I can simplify to 2 pi over 3. All right, how about this one? Negative pi over 12 radians. I know it's radians because I don't have a degree there. We are going to multiply by 180 degrees over pi radians. Now, what happens here is we end up with degrees on the top. This becomes negative 180 over 12 degrees, which is negative 15 degrees. All right, couple more. Negative 40 degrees. We are going to multiply by the conversion, 40 degrees times pi radians over 180 degrees. We want the degrees to cancel on the top and the bottom to leave us with radians. That is going to be negative 2 pi over 9. And we leave things in terms of pi. We'll see why when we look at the unit circle and we start looking at angle measures. All right, couple more, and then I'll let you guys finish up the rest on this page. How about this one? Negative 6.28. This is a little bit tricky. This is not degrees. This is radians. It's radians because there is no degree sign there. So if there was a degree sign, then we'd know it's in degrees. Because it doesn't have anything, this is radians. So we want to convert it to degrees. We're going to do this. We're going to multiply by 180 degrees and divide by pi. That is something you're just going to do in your calculator. This is negative 359.82 degrees. And we'll see later, 2 pi radians is equal to 360 degrees. Well, 2 times pi, if we use 3.14, is about 6.28. So that's why it's almost about 360, and then negative for the sign. All right, I'll let you guys finish up the rest of these on that page. The answer key will be posted online under the lecture notes answer key. All right, last couple of examples here. I'm going to let you guys read that. We'll come back to this when we talk about the unit circle. But this core concept is going to be helpful in the last example that we do. So we can calculate the arc length and the area of a circle following these two formulas, as long as we use the angle measured in radians. That becomes really important. The arc length equation and area equation look a little bit different if we're using degrees. So these only work if the measure of the angle is in radians, where arc length is S, the area of the sector is A, and the radius is R. Okay, last example. We've got this softball field. It forms a sector with the dimensions that's shown here. We want to find the length of the outfield fence and also the area of the field. So the length of the outfield fence, I'm going to highlight this in blue, is the whole length of this curve here. All right, so essentially we're looking for arc length. And then the second part is to find the area of the field. Okay, so let's find arc length first. The equation for arc length from right above is equal to the radius times the measure of the angle in radians. So the first thing we need to do is we need to convert 90 degrees into radians. So 90 degrees, we multiply that by pi radians over 180 degrees. That is equal to pi over 2 radians. That is a number we're going to use when we represent theta in our equations. So the radius here is 200. We're going to multiply that by theta, which is pi over 2. It's 200 because if you guys were to see this as a full circle, that is a really bad circle. But that's what we've got, essentially a quarter of a circle. Okay, we have 400 pi. Sorry, I can do math. 100 pi. And if you guys just type that into your calculator, you get something like 314.16 feet. That is the length of the outfield fence. All right, last one, area. We have the equation 1/2 r squared times theta. Again, theta is an angle measured in radians. We know r is 200, so we're going to square that, and then we're going to multiply that by pi over 2. Okay, this time we're going to get 10,000 pi. So the area of the field, if you just type that into your calculator, is pretty large. 31,415, almost 416 feet squared. Just using those equations from that core concept above. All right, email me if you've got questions. Homework will be posted online. Bye, guys.